Hi everyone, today we're going to be working on transformations. So I wanted to start off just by giving you a list of what the transformations are and talk about what we're going to do with them and play around a little with the graph so you can actually see them in action. So the idea behind transformations is that given some function graph, either one that you just know off the top of your head or one that I provided for you, if we make fairly simple changes to the equation of that function, we should be able to predict what they will do to the graph. And those simple things are adding or subtracting something from your x or your y, multiplying or dividing your x or your y by something, and then we separate off down here at the end, multiplying x or y by a negative number. We treat that as its own separate thing. So the possible results of this are your graph could shift. The whole graph could get picked up and moved up, down, left, or right by a certain amount. Your graph could stretch. So if it stretches in the y direction, that's getting taller. If it stretches in the x direction, we'd probably call that getting wider. The graph can also compress. So instead of getting taller, it could get shorter. Instead of getting wider, it could get skinnier. And then the last two, the negative signs, are flips. You can flip a graph upside down, so over the x-axis, or you can flip a graph side to side, which is over the y-axis. So those are the things that we're going to do to graphs, and at the same time, we're going to be recognizing how those are related to the equation. So the first thing that I want to do is actually jump over to Desmos and just play around a little bit. Okay, so what you're seeing here, the purple graph, is a function that I've created. I do want to know that if you want to do something like this yourself, where I've typed in f of x, you could type in something like x squared or the square root of x. And as soon as you type in something like y equals x squared plus c, you should see an option pop up right below that to add a slider, and that will give you the little c slider that you'll see me playing with. So I've created my own function just so it'll look a little more like some of the piecewise things you'll see in your homework, but you can absolutely do this with some known functions as well. All right, so original graph in purple. I'm going to turn this first one on. You're not seeing anything right now because my c is 0. So this is just f of x. It's sitting right over the purple graph. So I'm going to play around with what if we change that f of x plus c, the top equation you're seeing, what if we change the c value? So there's f of x plus 1, f of x plus 2, f of x plus 3. We could slide this around or zoom out a little so you can see more. 4, 5. And maybe you're seeing that if I take my f of x and on the outside I add a number, it moves that graph up. And you're only seeing the integer values, so this is moving by 1, 2, 3, 4. You could move by 4.5 or 7.1 or anything like that. Any of those are possible. I'm just trying to keep it simple for you. If we go back to 0, we can now look at negative z values. So it's really like f of x minus something. So if we do an f of x minus 1, this is what we get. Minus 2, minus 3, minus 4, minus 5. So this first equation that you're seeing, that's the vertical shifts. That's shift up or shift down by whatever your c value is. Positive is up, negative is down. That at least is fairly intuitive. Let's go back to c equals 0. And I'm going to switch to the second equation, f of x plus c in parentheses. So now we're adding something to our x value, not our y value. Let's just play around. If I go to c equals 1, that's what I get. So that is f of x plus 1 in parentheses. This, I think, is a little counterintuitive. I think most people, if they're thinking add 1 to my x's, they think their graph will shift to the right one, and it doesn't. And there are good reasons for that, and they're a little tricky conceptually, but I'll try and say them multiple times. The reason is that when we do transformations, we're trying to make this simple process where we do one operation, plus 1, and it either changes our x or it changes our y. It doesn't change both. But the truth is that for functions, if you change your x, it does change your y. So it's almost like what we're having to do here is say, how would we undo what we're seeing? So when you're changing x, you're actually having to do the opposite to see what would keep your y the same. So if we do an x plus 1, we actually have to plug in numbers that are 1 smaller than what we originally would have plugged in to get the same y values. And if we do x plus, oh, I'm going the wrong way, x plus 2, it slides to the left more, x plus 3 more, 4, 5, 6. If we subtract, if we do f of x minus 1 in the parentheses, that actually shifts to the right one. Minus 2 is right 2, minus 3 is right 3. So if you have an x plus a number in the parentheses, it's going to do sort of the opposite of what you'd expect. A plus will move it to the left and a minus will move it to the right. Okay, let's go back to 0. Let's look at this graph. So c times f of x, you're multiplying your y values by something. So first thing I'm going to do, oh, and the color matches here. That's okay, though. I think we'll be able to tell. So now they're the same. This is 1 times f of x. What if I make it 2 times f of x? And what if I make it 3 times f of x? And what if I make it 4 times f of x? And 5 times f of x? And this might be a little tricky to see, but what's happening is you're doing exactly what we said. You're multiplying all your y values. So looking at 2 times f of x, if I pick any point on this graph, negative 1, 2, when I double my y value, that point should land at negative 1, 4. And there you see it. If I'm looking at this top corner, 0, 3, when I double my y values, that should land at 0, 6. And there it is. So this is vertical stretch by a factor of 2, doubling all your y values. This is vertical stretch by a factor of 3, tripling all your y values. Okay, I'm going to mess with this just a little bit because I don't actually want to play with negative here. I want to play with decimals. Okay, so I fiddled with my slider just a little, so it'll tick me through the numbers between 0 and 1. So the distinction here is not between the positive and the negatives. It's between multiplying by something bigger than 1 and multiplying by something between 0 and 1. So right now I have c equals 1, so I'm just looking at y equals f of x. If I go c equals, let's go down to 0.5, there it is. We've now made our graph shorter. In fact, we've made it half as tall. So any y value here is now cut in half on the new graph. And if you multiply, so that's multiplying by 1/2, cuts the y values in half. If you multiply by, we'll say roughly a third, that's a little bigger than a third, that'll be a third of the original height. So this is vertical compression. If you multiply by a number between 0 and 1, you're going to get vertical compression. All right, let's go back to 1, and let's do the same thing for f of c times x. So now we're multiplying our x's, not our y's. So since I already have this set up for the numbers between 0 and 1, let's start with those. So this is just looking at the original function. If I slide this down to 1/2, because that's a fairly easy number, again, this is a little counterintuitive. I would think if I multiply by x's by 1/2, my graph will get skinnier, but it's actually getting wider. So if we look at the endpoint, 2, 1, when we multiply our x's by 1/2, we actually get the 0.41, because the real question is, if I want to get that same y value of 1, what do I have to do to my x? And the answer is I have to plug in something twice as big so that once it gets cut in half, the function will think it's getting 2. Notice that the points right on the y-axis actually don't move. So 0, 3, when I double my x, stays at 0, 3. But, wrong graph. There we go. Negative 1, 2, when I double my x, lands out at negative 2, 2. So the graph is twice as wide. So this is horizontal stretch. If you multiply by small numbers in the parentheses, you get stretch. Okay, I'm going to fiddle with my slider once more. All right, now I'm set to look at c values bigger than 1. So right now I'm looking at my original function, and then if I make that c equals 2, that's f of 2x, that's f of 3x, f of 4x, 5x, and as usual, the x's are counterintuitive. If you multiply x by 2, it actually cuts your x values in half. So let me go back to that 2. Original x value 2. To get the y value to stay the same, you'd have to now start with a 1. So your x value is half as big. Okay, last 2 is just the negative, so I'm just going to type them in. So we can keep the same function. Let's just get rid of that C for now. So if we put a negative out in front, it flips your graph upside down. I think these are both fairly intuitive. There's a lot to keep track of at first, but hopefully this one will be okay. And then I don't know if this is the best function to see this with, but you'll get lots of chances. If we put the negative inside, it flips it over the y-axis. So there's original and there's new is flipped across. So those are all your transformations. That's just a quick rundown, and then we'll do lots of examples.